Okay. Okay, so ladies and gentlemen, I think we can now proceed. So, Dimpo, you've just indicated that everything so far is clear, ne?
Yes.
Okay, so let me see. I think what I'm going to do now is to remove all of this information, and then from there, what I'm going to do is to draw that graph and also try to explain what's going on over there. So let me try use a different marker. So obviously we've got that vertical x-axis. Wait, I think I'm going to need some space. So let me not do it that long and maybe make it that short. Make it that short and have that line. So we've got velocity, which is obviously in meters per second. And we've got 0 there. We've got 10 there. We've got 27 there. We've got 29.6 over there. On the negative side, we've got, let's say, negative 25. We've got x. Okay, let me just leave it there and start to explain what's going on. So obviously, remember, we had that building over there, and then we've got the ground. This is the ground. This is that building. So guys, I need you to pay full attention now. Remember, we've got a ball which is being thrown vertically downwards. Dimpo, can you try to unmute your mic because you requested for this to be explained again? Can you try to unmute your mic? So obviously, this object is being thrown vertically downwards now.
Mm-hmm.
Which means it has a certain V initial, which is a positive V initial. So from the graph, this is that V initial, which is 10 meters per second. So my question to you, as this ball strikes the ground, is it decreasing or increasing its velocity?
I think it's increasing.
It's increasing, ne?
Yeah.
So that is the reason why this graph it's in that direction. Can you see the velocity is increasing? Can you see?
Oh. Mm-hmm.
Which means, as you can see, they've used dotted lines over there, ne? So they are simply saying, as it strikes the ground, its velocity increase, and it takes 2 seconds for it to reach the ground. Does it make sense? Which means its V final, which is positive, it's equals to 29.6. I'm not sure if you understand that part.
Yeah, I understand.
Let me quickly try to let me just try to plug, because I see I think I've got something like 20%. So I just want to make sure that I charge my phone while the lesson is on. Let me just quickly, okay, it's charging. So guys, what I've explained is that the initial velocity is 10 meters per second. This is the velocity at which the object is being thrown vertically downwards. So it strikes the ground at that velocity of 29.6 meters per second. How long does it take for that object to reach that ground? It takes 2 seconds. So Dimpo and everyone else, does it make sense so far before I continue explaining that part of the graph?
Yes, sir, it does.
Mr. D, are you also able to confirm if it makes sense up to this point? Or anyone else who's able to confirm if we're all on the same page? Okay, I'll make an assumption that we are all on the same page. So guys, now I need you to notice something. Can you see that line? It now starts on the other side of that axis. Can you see, Dimpo? It starts somewhere there. And you can even see they've indicated with a dotted line to say where the velocity is x. This is that point where this object is now changing the direction. Remember, the negative side of this graph represents the opposite direction. So the graph started on the positive side. Obviously, this is where it was thrown vertically downwards. So that means everything on the negative side, it represents the motion of the object as it goes up or it's moving upwards. So that means this object, it now bounces at a certain velocity. And that velocity, which is a negative velocity, its V initial is equals to negative x, or it's equals to x. Obviously, it's going to reach its maximum height, where its V final is equals to 0 meters per second. That we know. So, Dimpo, I want you to notice something. Remember, it starts or it leaves the ground at velocity x. Ne? As it goes up, what happens to its velocity? Is it increasing or is it decreasing?
It's decreasing.
It's decreasing up until it's 0. Ne?
0 is.
So that's why this graph is in that direction. Can you see? The velocity is decreasing, it's approaching 0. Can you see? Until it's 0, which is that point over there. Ne? And also, we are given the time there, which is 4.955. Mr. D, are you still on the line? I see Lebohang, Lebu still on the line. So, Lebu, does it make sense so far?
Yes.
Okay.
Yes,
So
sir, I
obviously,
everything so far.
okay. So obviously, at that point, it is going to now change direction and strikes the ground. So my question to you guys, as it now leaves that maximum point and strikes the ground, what happens to its velocity? Is it a positive velocity? And again, is it increasing or decreasing?
It's increasing.
It's increasing. The velocity is increasing. And again, in the positive direction, isn't it?
Yes.
That is why this graph, we just extend it up to somewhere there. So notice the difference. This graph, it cannot extend above that point. Why? Because after this ball strikes the ground and it bounces, it cannot bounce above that point from which it was thrown vertically downwards. So that is the reason why that line, it ends somewhere there, just below that below that velocity, which means it's just an indication that after it hits the ground at that velocity, as it leaves the ground, it doesn't leave the ground at the same velocity. So that velocity is represented by a velocity x. I think when we do calculations, we'll find out how much is that velocity. But what you need to understand up to this point is that that object, it bounces and reaches its maximum height, where its velocity, this is the turning point, where its velocity, it's equals to 0, and then it changes direction. That's why we've got now a line extending on the positive side, and obviously it strikes the ground, which is that point over there, which means now its V final is equals to 27. This is the final velocity as it strikes the ground from that point. So what happens after it has hit that ground? It obviously bounces back up until it reaches its maximum height, where we obviously know its V final is equals to 0. But now, what is its initial velocity? The initial velocity, it's equals to, obviously, it's going to be that negative 25. So guys, I'm not sure if we are still on the same page.
Yeah, we are together.
So let me see. That point over there, it represents that ball as it strikes the ground. And obviously, after striking the ground, it leaves the ground at a certain velocity, which is that velocity. It's indicated there to say at that time, which is 8, at time 8. This is where it changes direction. As it changes direction, what happens to its velocity? Is it decreasing or increasing? Obviously, it's decreasing until its velocity is 0, which is that point over there. And the time is not given there, but the time is t. And again, there's that time which is given over there, which is 7.71. What is that time? At that time, that's where, let's see, that's where that object strikes the ground. So that means, guys, from time 0, this object is being thrown vertically downwards. It takes 2 seconds for it to strike the ground. Then it changes direction at that velocity of x, and then it goes up until it reaches its maximum height, where time is 4.955 seconds. From there, it strikes the ground again. It strikes the ground again on the graph at that velocity of 27, and again it changes direction. Let's see, what is that? This is 20 V initial is 25. So guys, this is velocity which is 25, which is the velocity at which it leaves the ground to reach its maximum height. So let me see, where was I? So I was explaining that part to say this point is that point on the diagram. So it strikes the ground. This is where it strikes the ground at that velocity of 27. And again, from there, what happens? It changes direction at that initial velocity of 25. Obviously, it's a negative 25, which indicates the direction. We know negative, it means it will be going upwards up until it reaches its maximum height, where time is t. So, guys, this type of questions, they're a bit tricky way at the same time when I'm explaining. So I'm not sure if up to this point there's no one who's confused, or otherwise Mr. D, Dimpo Lebo, Alna question so far.
No questions.
Okay. Mr. D, Dimpo, no question so far.
No question.
Okay. It's
No
fine.
questions.
So I think let's try to answer the questions. In that way, I think we'll have a better understanding of what is going on. So obviously, guys, I haven't done this question before. I'm doing it for the first time with you guys. So I think we'll need to help each other with this question. It might be confusing, one thing for sure. So let's now try to check what is our first question. So our first question, which is 3.1, says write down the speed with which the ball is thrown downwards. So guys, based on the explanation that I've given, and again based on this diagram, are we able to tell what is the velocity or the speed with which the ball is thrown downwards? And this question is allocated 1 mark, which is an indication that we do not need to perform any calculations. So guys, is there someone who wants to guess what the answer could be? And also, in case if you need to refer to this diagram, just let me know. So let's call this our sketch. So if you want to refer to the sketch, just say bring back the sketch. Then I'll bring it back so that you are able to provide an answer. I hear there's someone who wants to make a comment. Who is it? Who is it? Is it Dimpo? Is it you who wants to give it a guess?
Yeah.
It's the
So what is the speed with which the ball is thrown downwards? Or maybe
From the sketch. From the sketch, I think
it's positive.
meters 10 meters per second.
Positive 10 meters per second. Anyone in disagreement?
Yeah, positive.
So guys, are we all saying is 10 meters per second?
Yes,
Mr. D?
Munir?
Are you also in agreement that it's 10 meters per second.
Can you read that question for me again, please? The connection is poor this side.
Connection is poor, but then I just wanted to check if you also agree that the speed with which the ball is thrown downwards is 10 meters per second.
Yes, from 10 meters per second.
Okay, great. So now let's move to question 3.2. So the question says all parts
before you
of
move on, sir, is it necessary to write a positive sign?
A very good question asked. I think for the purpose of being consistent, let's write it as positive 10 meters per second. But I think, your question, it actually brings us to something. Remember, we've got speed and again we've got velocity. So between these two, speed is a scalar quantity, and then velocity is what we call a vector quantity. What is a scalar quantity? A scalar quantity has got a magnitude only. I'm going to explain all of this. Then a vector quantity has both magnitude and again it has direction. So Mr. D, if they say what is the velocity, that means if it's 10 meters per second, you must also say either upwards or downwards. Why? Because a velocity, it's a vector quantity. It has the magnitude or the value, which is 10, and again direction, which could be upwards or positive. But if it's a speed that the question wants you to either calculate or determine or write down, so you can just give the magnitude, no need for direction. So in short, in answering your question, we actually just need to say 10 meters per second. No need for that positive sign. Why? Remember, a positive sign or a negative sign refers to the direction, of which on that question, they are not concerned about the direction. They just want to know the speed at which the ball is thrown downwards. So, Mr. D, I'm not sure if you understand this part, because I think your question brought us to this important information. So I'm not sure if you now understand, or otherwise if I've answered your question of whether it's necessary to write that positive sign.
Yeah, no, I understand.
Makes sense, ne? Okay, so I'm just going to remove all of that, then we move to the next question. So ladies and gentlemen, let's check question 3.2. All parts of the graph have the same gradient. Give a reason for this. So this is one of those tricky questions which can be answered in different ways. So I'm just going to explain to you what happens on that question. So guys, the gradient, the quantity that influences the gradient is the gravity. So obviously the gradient that they are talking about is that gradient. So they are saying we've got that line in that direction. So this part of the line, it's not at that angle or at that angle, but it's in the same angle as that initial line. So it's also in that same gradient. And again, that one also, it's in the same gradient as all of these lines. So the reason to that is because in every situation, as the ball strikes the ground, bounces, and again strikes the ground, bounces, obviously, this is the end of that, the end of the trip of that ball. It ends somewhere there, the top at time t. So obviously, as all of this is happening, guys, G is the same throughout. It's equals to 9.8. So, Mr. D, in answering this question, you can see, you can say the gradient of the graph is the same because the gradient, or not necessarily the gradient, but the gravitational acceleration is constant or is the same throughout. Guys, I'm not sure if that makes sense, or otherwise if there's someone who can give a better explanation so that it serves as a confirmation that we are all on the same page. Lebo?
Yes, sir.
Why Kwishisha?
I understand, sir.
Okay. Mr. D, Dimpo, does it make sense? So ntoke trangwe tlhalosa kore object here from the top of the roof, as it strikes the ground, G is the same. As it bounces, G is the same. As it strikes the ground, G is the same. As it bounces, G is the same. So that's why I'm saying the gradient is the same because the gravitational acceleration is constant or is the same. So yeah, kushishe Dimpo, Mr. D.
Yeah, ke
Why it's hard, ne? So what I explain until ore G is constant. So that's why I'm saying you can explain it in different ways, but what matters the most, we need to have that part in your answer. So guys, we can now try to move to question 3.3. We've got 3.3.1. So the question says calculate. Obviously 3.3 says calculate height from which the ball is thrown. And that question is allocated 3 marks. So no Banyaka height. Banyaka height from which the ball is thrown. So this is the height that they want you to calculate, which is changing y. So guys, I'm going to tell you something that you should remember at all times. When it comes to this chapter, whatever that they want you to calculate, you must be having 3 quantities and you calculate the 4th quantity. So before we go to the formula sheet, let's try to check what information we've got. So we obviously know the V initial. We obviously know the V final. So this is the second quantity that we know. We obviously know, ladies and gentlemen, that we've got a positive G, which is 9.8, which makes the third information that we have. So the 4th information is what you need to calculate. That means we can now go to our formula sheet and try to find a formula, a suitable formula to calculate what is it, the height from which the ball is thrown. So guys, do you now understand the question before I go to the formula sheet? Can someone indicate if what I've explained makes sense?
Thanks, sir.
Makes sense, ne?
Yes, sir.
So obviously, we know V initial is equals to 10 meters per second. 10 meters per second. So Mr. D, in this case, it's important to say positive 10 meters per second. So why? Because this is a velocity that we're dealing with, which involves direction. And again, what else have we got? We've got V final, which is positive from our sketch is positive 29.6 meters per second. Positive 29.6 meters per second. Obviously, we know G is also positive 9.8 meters per second squared. And what the question wants us to calculate is that, guys, your final answer should be in meters. So we've got that formula over there. We cannot use that formula because it does not have delta y. We've got a second formula there. Remember, this is the same thing. So if you're dealing with objects moving horizontally or from left to right, you use delta x. You remember the Cartesian plane, this line represents the x-axis and that represents the y-axis. So that's why we concentrate on that formula with delta y, because we're dealing with objects moving up and down. So ladies and gentlemen, let's check. We've got V final there, yes. We've got V initial there, yes. We've got a acceleration there. They've just decided to write it as acceleration, but we know that A represents acceleration, of which for up and down objects we refer to it as G. So there we've got G, delta Y, we still have delta Y, which means we can still use this formula. So let's check if we can use that formula. Remember, there are multiple ways in which you can answer this question, but at all times, try to find the simplest method. So let's see. We've got delta y, we've got V initial, time. I think time might be an issue. Let me quickly go back to that statement and check if where is that question? Check if we've got time. It seems like we do have time. It's 2 seconds. What does it mean? It means for that object to strike the ground, it took 2 seconds. So it seems like also we can still use that formula. So I think, guys, let's try to use all the possible formulas so that we test if we find the same answer. So let's see. Time is there, delta y, V initial is there, time and G. Okay. And again, let's check. With this one, we've got V initial, we've got V final, we also have time. So guys, let's try to quickly perform 3 calculations and see if we're going to find the same answer, starting with that first formula. So obviously it says, let me use this marker. So obviously it says, that formula, it says V final squared, it's equals to V initial squared plus 2, obviously is G delta Y. This is what we want to calculate. Let's substitute our V final from the sketch. What was our V final? So it was 29.6. So guys, in case if you're not following, just make sure to to either stop me or ask a question. So let me go to that sketch so that we are all on the same page. So obviously V initial, it was 10. We said V initial is 10 u squared plus 2, G is 9.8 close delta Y. So remember guys, V final is positive. Even though I didn't write positive, it's positive. V initial still is positive. G is also positive. So obviously, you're going to say that V final minus that, you get an answer of which you divide by 2 into that. Then that is going to be your delta Y. So guys, calculation wise, I'm not sure if you need if you need me to show that step by step. But I think it's not a complicated calculation to do. So, okay, guys, so it's obviously 29.6 squared minus 10 squared. This is equals to 2 into 9.8 delta Y. So we are going to divide by 2 into 9.8. Also, you do the same on the other side. Why did we have to divide by 2.98? It's because we wanted it to cancel so that we just remain with delta Y, which is equals to the whole of that. So ladies and gentlemen, let's try to punch all of that on a calculator and see what answer we get.
Sir, we reuse our 9.8 meters per second. Yeah, positive. Downwards again, okay, positive. All right. Thank you, upwards me. Positive. If you can negative.
Negative. N. Be careful between the velocity of V initial le final or ke efe ye yang up, ke efe ye yang down.
Oh.
So that sign here, positively negative, it apply more G le more V initial le more V final.
Oh, okay.
Okay. All right. So no har puncher bono recreating. So obviously it's 29.6 close squared minus there it's 10 squared, it's equals to that. You divide by 2 into 9.8, it's equals to 39.6. So guys, I'm getting 39.6. I'm not sure if you're also getting the same value. Anyone who has done a calculation and got the same or a different value? Level, Mr. D, are we getting the same answer?
The same answer, sir.
Okay, same answer. So now I'm going to remove all of this. Then let's try to do the same, not necessarily the same, but try to answer that question, but using a different formula and compare if we're still going to find the same answer. So obviously, we have tested that formula. So now let's use the other formula. So we've got delta Y, which is equals to V initial delta T plus half G delta T squared. I think I can add on that information to say time is equals to 2 seconds. So ladies and gentlemen, it's very, very much important that you are able to to know that the time is 2 seconds. Can you see? Initial velocity was 10, final velocity was that, and all of that happened within or over 2 seconds. So let's now substitute. We've got our V initial, which is 10. Time is 2. plus half G, it's 9.8, close, time is 2 squared. Then you can just punch all of this on a calculator and check if you get the same answer as we got using the same formula. So 9.8 close into 2 squared, 39.6. So I'm still getting 39.6 meters. So Mr. D, this is an indication that you've got multiple ways in which you can answer this question. So now I'm going to remove all of these and try to use a different formula. Let's check. Where is that formula? There is the formula. So it's delta y, it's equals to into, we've got V initial plus V final, the whole of this divided by 2, a delta t. So ladies and gentlemen, what is our initial velocity? It's equals to 10. Ladies and gentlemen, what is our V final? It's 29.6. The whole of this is divided by 2. Ladies and gentlemen, it takes 2 seconds. So without even using a calculator, I know those cancels. This plus that is 39.6 meters. So ladies and gentlemen, that means you can answer that question using any of the methods. So not necessarily the methods, but using any formula. It all depends on what information you have. So ladies and gentlemen, are you all satisfied with question 3.3.1? Can we now move to question question 3.3.2?
Yes, sir, we can move.
Okay, let me also remove all of that. Okay, 3.3.2. So the question says calculate a time t shown on the graph. Most importantly, Mr. D, they're saying calculate time t, which means our final answer should be t is equals to something seconds. The time, which is in seconds. So ladies and gentlemen, based on the graph, what information do we have? Remember guys, we just need 3 quantities for us to be able to calculate the 4th quantity. So if we can check, for us to get information related to that t, we should be concentrating on that part of the movement of the ball. We cannot concentrate on that part because it doesn't bring us to that point t. So our concentration, it's at that point t. So what we know about that point t? Obviously we know, ladies and gentlemen, the V initial, it's equals to negative 25 meters per second. Ladies and gentlemen, we know V final, it's equals to 0 meters per second. Guys, we know G, it's equals to positive 9.8 meters per square seconds. What else? The time. I think if we can know how long it takes for that object to reach its maximum height on the second bounce, then we can add all this time to know that time t. So ladies and gentlemen, I'm not sure if I'm confusing each of you there. So this is the information that I'm gathering. V initial, no, this is the final velocity, but V initial, it's negative 25. V final, it's 0. We know G, it's 9.8, which is positive because it's acting in the downwards direction. But now, what I'm trying to do, ladies and gentlemen, is to calculate the time it takes for this object to bounce and reach that maximum height. If it takes 2 seconds, then it means I'm going to add that time, and that time, which is more like 2 seconds is going to be just that time. This is the time that I'm going to calculate using this information. Then as soon as I know it's 2 seconds or whatever time it is, I am forced to add it with all of that time. Why? Because t, it's not 2 seconds, so it cannot be 2 seconds because from there to there is 2 seconds. Then from there up to there is 4.99. From there to there, it's 7.71. From there to there, it's 8 seconds. From there to there, it has to be a bigger time, which is bigger than 2 seconds. Guys, I need someone to unmute their mic and say they don't understand. Or otherwise, if it makes sense also, please do make an indication to say you understand what I'm trying to explain. Dimpo ya kwala.
Yes,
Why kushisha ne? Mr. D, Lebohang, why swara?
Yes, sir, it's fine.
Okay, so now let's try to calculate time. So let's go back to the formula sheet and check for a suitable formula that you can use. So we need a formula that has a V final, V initial, and G where we can calculate time. V final, V initial, G, we can calculate time. So can you see? It seems like that first formula can be used. G delta T. What is our V final? It's 0. What is our V initial? It's negative 25. What is G? So G obviously is positive 9.8 delta T. Now we can calculate. So you transpose, then you've got 25, which is equals to 9.8 delta T. Then delta T is equals to this or that divided by that. So it's 25 divided by 9.8. Let's check. 25 divided by 9.8. It's equals to 2.6. It's equals to 2.63. Let me round it off to 2 decimal places. So can you see, ladies and gentlemen, time, that time, so for this object to bounce off the ground from there up to there, it takes 2.63. It takes 2.63 seconds. So that means that time is 2.63 seconds. So I need to add all this time up to there plus that it's going to give me the value of time t. So that's what I've been trying to explain. So that means time t is going to be equals to I think it has to be, let me see, I think it has to be 8. Can you see? From there up to there, it's 8. And from that point to there, we know it's 2.63. So that means time is 8 plus 2.63, which is equals to 10.63 seconds. Most importantly, make sure you note or you write the SI unit, the International Symbol Unit for measuring the time. In physical sciences, we measure the time in seconds. So, ladies and gentlemen, are you all satisfied with question 3.3.2? And remember, guys, that question is allocated 4 marks. So it's actually a lot of marks, but the calculation it's simple. So it's actually a matter of you understanding the given diagram together with the given statement. So guys, I would encourage you to watch those lessons that I've made where I explain all different types of graphs. I can assure you that if you can watch that lesson, you'll be able to fully understand all the questions based on the graphs. So ladies and gentlemen, are we all on the same page? Are we ready to move to the next question?
Yes, but for me, I was going to say G is equal to negative 9.8 because velocity is also negative 25.
Okay. So you're saying you were going to say G is negative 9.8, ne?
Yes,
Why? Because velocity is negative. Is that the reason why?
yes,
But remember, G can never change its direction. If for those previous calculations our G was positive, then throughout all the questions your G has to be positive. And again, remember, where is that statement, ladies and gentlemen? Can you see? Take downwards as positive direction. Can you see? So that means for all the downwards direction, our G or our yes, our velocity and gravity will be positive. So if you say G is negative, it's more like now G, if this is the ground, so it's more like you're saying G is now, or gravity is now in that direction. I'm not sure if it makes sense, guys. Mr. D, Dimpo, I can see it. Does it make sense why G has to always be positive regardless of whether the object is going up or down? Does it make sense? Level, why understand that? No?
Yeah, for now.
food
Yeah.
Yeah, for now it makes sense because the law of gravity. That's why I feel I
Etc. in one direction.
yeah.
So, level, do I still need to explain it again differently?
No, I understand.
Okay. So
For
now,
me, yes, because what
so Mr.
for
D,
me, yes, because
it,
always the G is always pulling is always pulling down.
so that is the simplest, but luckily she
So
understands it now.
if the
So
object is going down, so obviously is acceleration.
yeah, so Lerato, this is the earth, ne? This is the earth. Ke ground, ke ground di mola. So are ke die so ke die a flat ke ground mola ke ground. So every time ho foshetsa ball ko dimo, e tlo no boya e busha ke eng ke that force of gravity. So gravitational acceleration ke yone e lo reng ke 9.8. So that means if initially re tšea this g as minus, obviously if this
Yes,
object
sir.
e ya godimo, v initial it's going to be positive, g yona e remaina as negative 9.8. He object ye e tlo boya e busha ke that g which is always exerting towards the ground. Velocity e tla be e le in the negative direction. So g yona ha e change. The moment o bona o change g, then it's more like ora g a e sa exerta dilo downwards, so no e disha udimo. So kora reng everything e lo reng is not attached to the earth. Akere if re builda ntlo ona le foundation, so it's attached to the earth. So everything which is movable o tlo kry a floater in the air. Why one? And this has never happened since I think since whenever the earth was created, it has always been exerting towards the center of the earth. It makes sense now. No, Lebone.
It's clear now.
Okay, so now let's move to the next question, which is 3.4. 3.4.1. So guys, normally when you're given this type of questions, question 4.4, no, 3.4.1, it's allocated 1 mark. So normally in this case you don't need to stress that much, or otherwise you don't need to perform a lot of calculations. You might find that you don't even need to perform any calculation because almost everything it's a given. So guys, question 3.4.1 says write down there. Can you see the difference, guys? The previous question they said calculate there, that means you need to perform calculations. But now for this question they say write down there, which means you need to pick that information from that graph or the statement and write it down without the need to perform any calculation. So they say write down there 3.4.1 time that the ball is in contact with the ground at the first bounce. This is a tricky question. So Mr. D, banya ko tseba hore akere this is that ground. Ball ela from the top e tloile mola ya betha mo fase. So the question wants to know the time that the ball is in contact with the ground at the first bounce. So they want to know how long did it take before that object bounces off the ground. So guys, this information should be given on that graph. Remember, we're referring to the first bounce, and this is the first bounce. So what happens is it took 2 seconds. It took 2 seconds. You can see with that broken line, it took 2 seconds for that object from that point up until it strikes the ground. Name. But as it leaves the ground, it doesn't leave at the same time, or it doesn't leave from that 2 seconds. So you can see there's that space in between. and that object, it starts to leave the ground after 2.2 seconds. So that means this object, it takes 1-2 seconds, it strikes the ground. Then there's that time where it waits. And then after that time, it now leaves the ground. So that means, let me just try to redraw that. It obviously takes that time, which is 2 seconds. Then from there, after some time, that's when it leaves the ground. So that means that time is the time at which the ball is in contact with the ground. Guys, I'm not sure if what I'm trying to explain makes sense. So, Mr. D, I know the same time is nore pa then gone. Kuring ibe tafasi then ya khone ya udimo. So there's that time where this object is in contact with the ground. Guys, I'm not sure if what I'm trying to explain makes sense, because to me, I know exactly what the question wants us to provide as an answer, but I'm trying to explain so that we're on the same page. Dimpo, a ke tsebe reng ya kwishišana Lerato.
Yes, sir, it makes sense. In other words, I know, sir.
No. Try to explain. Maybe we can try to explain or get like a better explanation.
In other words, we would say change in T is equal to T2 minus T1.
You see? So that is the change in T, which is equals to T2 minus T1. Can you see? You are now getting to an answer to this question. Dimpo, Mr. D, akitseboring rakwana kaofela now. Question ya kwisha ring banyaka eng? Lerato, I think if there are no questions, it means it makes sense. So simply, it means T2 is 2.2 minus 2, which is equals to, what is it? Is it 0.2 seconds? It makes sense, Lerato. So obviously, this is how you're going to do the calculation, isn't it? I mean, Kiman level. Is this how you're going to make the calculation to answer that question?
Yes, sir.
Okay. So, Mr. D, Dimpo, if there's no question from your side, then I'll just make an assumption that we are all on the same page. So now, let's move to question 3.4. 0.2. Write down time at which the ball reaches its maximum height after the first bounce. Write down the time at which the ball reaches its maximum height after the first bounce. So obviously, from there, it strikes the ground, then it leaves the ground, then it reaches its maximum height. So this is the time that they want to know. So on the graph, obviously, remember guys, it is thrown at 10 meters per second. Its velocity increases. It strikes the ground at 29.6 meters per second. Then what happens? It changes direction as it bounces off the ground. Then it bounces the ground in that direction where it reaches its maximum height. So this is the first bounce. This is the first bounce, and this is where it reaches its maximum height. So this is the time that you must provide as an answer to this question. I'm not sure if, guys, if it makes sense based on what I've explained. Guys,
Yes, it does.
It makes sense, ne? Mr. Dimpo, I'm not sure if you've got any questions up to this point.
Yeah, so far, everything.
Make a sense, ne?
Yes, yeah, it makes sense.
Okay, so now let's move to question 4.
Everything makes sense.
Okay, let's move to question 3.4.3. They say the value of x.
Sorry, sir. Before you move on, can you go back to the diagram? I just wanna ask something there.
Yeah. Mr. D. Mr. D, network. I think in the meantime, guys, let's continue. Then I think we'll visit that question towards the end of the lesson. So now the question says, write down the value of x. What is x? What does x represent? I'm not sure if there's one of you who'd like to answer that question. X representa ing. Is it time? Is it velocity? Is it a height? Is it a gravitational acceleration? What does x represent?
Yes, sir.
So its initial velocity.
Which initial velocity?
Initial velocity for the ball when it's leave the ground for the second time.
Let's see. Is it there or there? Let's say, is it A or B that you're talking about?
It's A.
It's A, ne?
Yes, sir.
Okay. So, do you want to guess what is the value of x? Because now you've got it right to say x represents the velocity. So now, what is that velocity? Do you want to guess, or you're not able to tell what is that velocity, ne?
I'm not able to tell, sir.
Okay. Okay, I understand. So, let's try to check something. One thing for sure, it has to be a velocity which is greater than 25. So there's something interesting about these graphs, ladies and gentlemen, especially that one which crosses that time. Let me just try to redraw this graph, but only focus on this line. This is that time. So I just want you to notice something, guys. This is the final velocity. This is that initial velocity. So, ladies and gentlemen, what I want to explain to you is that obviously at that point, that's where the object is at its maximum height. And obviously, that point there, that is when it strikes the ground. And we know the velocity there is positive 27, which makes that velocity to also be the same. Remember, guys, if object here, it leaves the ground at 4 meters per second, and let's say it takes 1.5 seconds to reach its maximum height. On its way down, it is still going to take the same time, and it is still going to strike the ground at the same velocity. It only gets different when it bounces off the ground. So, ladies and gentlemen, what I'm trying to explain to you is that the distance or the time from there to there is the same time from there to there. In terms of the velocity, we just know the final velocity, of which, based on my explanation, it has to be the same velocity. So in short, ladies and gentlemen, I'm simply saying X, it should be careful of the sign. Obviously, it has to be negative 27 meters per second. Lerato, are you sure if it makes sense? No. Dimpo, Mr. D, are we still on the same page on this one?
Yes.
Yes, sir.
Level, it makes sense.
Yes, sir, it does.
Okay, so in that way, that's how you answer for that question. Let me just quickly try to redraw that graph. So obviously we know this is what happens as it strikes the ground. So this is when it strikes the ground at that velocity of 29.6. Then from there, what happens? It stays for some time in contact with the ground. We know that time is 0.2. Then, as it leaves the ground at a certain velocity of which it is going to reach a maximum height where its velocity v final is equals to 0. Then, as it strikes the ground, this velocity should be the same as that velocity as it left the ground. The same explanation as I said, if it takes 1 second to reach its maximum height, it still has to take 1 second to reach the ground, or the same level from which it was leaving the ground. It's only when it leaves the ground where this velocity and that velocity are different. That is why we refer to this as initial velocity as it leaves the ground, and we refer to this as the final velocity as it strikes the ground. Then we refer to this as the initial velocity as it leaves the ground. Then it's going to reach its maximum height and then still strike the ground, and refer to this as V final, whereby this V initial is the same as that V initial, and time obviously is going to be less than that, which is maybe could be 0.8. As it strikes the ground, it still takes 0.8. So guys, I think that was a conclusive explanation. So now we can move to the last question. In case if you've got a question, ladies and gentlemen, you can just ask that question. So guys, we're almost done with this question. So now we are moving to question 3.5, which says, is the collision of the ball with the ground elastic or inelastic? Give a reason for the answer using information in the graph. Is the collision of the ball with the ground elastic or inelastic? Give a reason for the answer using the information. So ladies and gentlemen, it simply means if you don't know the difference between elastic and inelastic, you won't be able to answer this question, even though a smart learner will guess between these two. But we are going to be able to know that you made a guess, because you might find that your reason is not corresponding with the answer that you guessed. So it's very, very much important that you learn the difference between the two. So I'm just going to give you an answer to this question, but as part of your homework, try to find the difference between the two, and again, and again provide a reason based on your understanding of the difference between the two, even though I'm going to give an answer. Remember, guys, for those of you who are not, having those private lessons, because remember, guys, I've got private lessons and general lessons. So this is a general lesson where everyone is welcome to join the lesson. But if you're doing a general lesson, then it helps towards the end of the year to know who learner was serious. So in that way, I'm able to include you in most of my lessons, especially when I do exam revisions towards the end of the year. And also, when we do winter school. So ladies and gentlemen, please do make sure that you check out the difference between the two, and again, you give a reason based on your understanding of the difference between the two. And most importantly, give that homework, send it to my Telegram inbox, not via WhatsApp. So guys, obviously I won't explain the difference between the two. So that forms part of your homework. So ladies and gentlemen, this is an inequality. Inelastic. The collision is inelastic. This is an answer to that question. By so doing, I score myself a mark. So based on the graph, ladies and gentlemen, you can see the time at which the ball strikes the ground is not the same time as the ball leaves the ground. You can see over there, you've got that change in time, where the change in time is 2.2 minus 2, which is equals to 0.2 seconds. So that means the ball, after hitting the ground, it does not leave the ground at the same time at which it strikes the ground. So that means it doesn't same time, boom, boom. Means it hits the ground, wait for some time, and then boom, it leaves the ground. So can you see, this is that space which is 0.2 seconds in that instance. Same applies there also. You've got that change in time, which is what? It's 8 minus 7.71, which is 0.71 seconds. So can you see? It means the time at which that ball strikes the same is not the same time at which it leaves the ground, which makes the collision inelastic. Why? Because the time at which the ball strikes the ground is not the same time at which the ball leaves the ground. So, ladies and gentlemen, this brings us to the end of our lesson for today. I'm not sure if up to this point you've got any questions. Lebo? Yeah, share.
So now, sir, what is the homework?
So the homework, you need to tell me the difference between elastic and inelastic. And again, still give a reason for this question based on your understanding of the difference between the two. Why understand the homework? Is that a yes?
I understand.
Okay.
Yes.
Okay. Dimpo, Mr. D, do you have any questions?
Sir.
No
Yeah,
question.
sir, I've got a question.
Okay.
I have a question.
Mm-hmm.
There's no other way the question is how long before it, like you see when it bounces down, it takes some time. There's no other way question can for it.
Mr. D, what's line ya how ya break? Ha ke a ukwa o bolela ka he there's that time it takes, or that time where it's in contact with the ground. So firstly, can you understand our ring? It's for which question? The question that we're having, it's for which question?
No, I'm just asking for myself. For the what if the question it comes, or there's no other way question can come? Like if they say calculate how long it takes, because it takes some time.
Okay, maybe let me try to respond. I'm not sure if in my response I'm going to cover the question that you're asking, because line how ya break Amara. In this case, any question could be asked. So you can still be asked the time that the ball is in contact with the ground on the second bounce. Yeah, I think this is the second bounce. So you still perform the same calculation as you did on that other side. So that means 8 minus that is the time at which that ball is in contact with the ground. And again, in this case, this is a question that is based on both of these scenarios. So a bouncer for the first time is in contact for some time. A bouncer for the second time, it's in contact with the ground for some time. But that time at which it's in contact with the ground is not the same, and again, it does not have to be the same. It is influenced by the speed at which that ball strikes the ground. So obviously, Mr. D, if this object it like a speed sa ko godimo, obviously it tlo tšea nako e nyane e le in contact with the ground because the speed or the velocity is high. So obviously after e bouncile, speed sela sa fokotšega. So he se tla mola wa bona gore speed is slow. So he se le slow is going to take more time in contact with the ground until ya mola, more time in contact with the ground until ya mola, then no is forever in contact with the ground because has a bounce and no idutimo grounding. So that time which is in contact with the ground, that time which is in contact with the ground, that time which is in contact with the ground, it's never the same. So Mr. D, I'm not sure if ke question ya how.
Yeah, my question, what if the question said calculate? How am I going to calculate?
Oh, if question really o calculate eng?
Calculate time takes before.
Yeah, break. I'm confirmele.
Time. This is set. Yeah.
Ne ke re line ya hao ya break mara confirmele o reng ke a understand. So o nya go tsiba if question really calculate the time it's in contact with the ground for hey bouncer mola. Is that the question? Lebo a ke sure if o kgonne kwa Mr. D because from my side ne break ha se ke kgone go isha ora e ba re calculate time for which case. But one thing for sure, if banyakile that time you perform the same calculation of 2.2 minus 2, in that case it will be 8 minus 7.71. Mr. D, I guess what question out here now?
Yeah, no, we'll talk about it. My connection is poor today.
Yeah, no, according today connection how poor.
By the way.
Yeah, but otherwise it's fine. I think. Okay, no, it's fine. I think I address on our private lessons, but otherwise you've got 8, you've got 7.71. So in case if the question said calculate the time the ball is in contact for that bounce, then you perform the same calculation as you did on that calculation or on that question. So, Lebo, as we wrap up, you don't have any questions, ne?
No questions, sir.
Okay. So, I think, I assume everything was clear. It seems like Dimpo is already gone. She sent an inbox to say she wants to quickly attend to something. So, guys, thanks very much for joining. This is that time where I sign out and say, my name is Desmond, and I'm out.